All right, guys, I don't have a PowerPoint for this, and I had forgotten that it was actually in the book, so we're actually going to look at, I think you said it was page 65. It's how to work the problems for section 2 and 3. This is actually going to be decimal, how to convert binary decimal numbers. I don't think I want red today. Yeah, I think it's on page 65, questions 2 and 3. And now we're not going to work those same exact problems. I'm going to make up some that are similar to them. But since it's not covered anywhere else in my lecture, I need to put it somewhere. So this is going to be my new slides. Okay. So let's go back to do a number. We're just going to do like 35. Okay. And I want to convert that to a binary number. So this is a base 10. And anytime you don't see the little 10 subscript, which means below it, it means it's decimal. Okay. So even if I just wrote 35, if I have nothing below it, it's decimal. Everybody okay? All right. So let's convert that to binary. All right. So if I convert this to binary, the first thing I need to do is get my column weights, right? So what's my first column weight? Far to the right. What's the next one? Next one? 16. What's the next one? All right, 64 is larger than 35, so I know I'm not going to have to go that far, right? So I'm just going to stop right there. So if I take 35 and I can't subtract out my 64, so I'm just going to skip it. Can I subtract out of the 32? Okay. I know I'm kind of backing up, but y'all didn't seem to, I didn't think y'all'd mind a refresher. So, all right. I can't take out a 16, can I? How about an 8? Oh, I guess I could have gone ahead and subtracted. How about a 4? How about a 2? All right. That leaves me a 1, right? All right. So my number for 35, my binary number is 100011. Did y'all have any problems doing that? Okay. I didn't really think you did. All right. So we started to find our column weights. We started with 1, 2, 4, 8, 16, and so on, right? If I'm going from right to left, they double. Do you see that? Okay. If I look at this from left to right, what happens? They half. Everybody okay? All right. So to find the numbers on the other side of the decimal sign, I'm going the opposite direction. So if I come down to 1, what is half of 1? So my first column weight is a 0.5. What is half of half? 0.25. What's half of 0.25? You know the next one? 0.0625. Then 0.03125. I'm just going to do these and stop right there. So you basically do the decimal number like you do the other side, except you have smaller decimal increments. Okay? So I'm going to I'm going to clear this out. Everybody got what they need from this page? All right. So going on, let's try to do one like, I'll make it a simple one. 50.75. Okay? The easiest way to do these is to do them in pieces. So we do what's greater than 1, and then we do what's less than 1. So we do to the left of the decimal and then to the right of the decimal, or vice versa. I prefer to do the big number first and then worry about the decimal number. Okay? So if we do the 50, we have 1, 2, 4, 8, 16, 32, and I know the next one's 64, so I'm just not even going to write it down. Okay? So if I subtract 32 from 50, it's been a long day, guys, I'm sorry. I have 18 left, right? So I can subtract the 16, and I have 2 left. I already knew this was an even number, so I knew I wasn't going to have any 1. All right, so my number is 110010 for the 50. All right, so now I'm going to put a decimal, and I'm going to do 0.5, 0.25. It's a little harder to know where to stop on this side. This particular one is easy because I made it that way. Okay, so now I take 0.75, and can I subtract a 0.5 out of it? Well, yeah. And I'm putting 0.50 just to keep my numbers aligned, guys. 0.50 is the same thing as 0.5. Everybody okay with that? Okay. Matter of fact, we talked about that this morning, didn't we? All right. So I have a 1 there. My next one's a 0.25, and obviously I can subtract it out too, can I? And that's my end. So 50.75 is 110010.11. Basically, yes. Because then you get into inversions. Y'all okay? Not as difficult as it looked? There's a couple of things that I need to tell you about decimals, though. Binary does not, in binary, we can't have perfect decimals. There are some decimal numbers that you cannot get in binary. One of those is, matter of fact, I'm going to change slides. One of those is 0.6. Okay? So if we did this and we do 0.5, 0.25, 0.125, 0.0625, 0.03125, 0.016125, 0.16125. Okay, that's as far as I'm going. Okay. So if I take 0.6 and I subtract out a 0.5, I get 0.1. Can't subtract out a 0.25, can I? Can't subtract out a 0.125. I can subtract out a 0.0625. And that gives me 0.0, let's see, let me do it the right way. All right, so let's see, it'd be 7, 3, 0.0375. So I can't subtract out, I'm sorry, I can subtract out a 0.03125. So now I have 0.00625. So I can't subtract out this one. I can't subtract out this one. It's about 4 more down the road before I can get something else. I can get really close to a 0.6. If memory serves, I can continue this down and I can get to about a 0.59784 something. Okay, it's kind of like pi. Y'all know how long pi is? You do? You'd be the only person I know of. It's very long. There you go. I had a high school teacher that had it on a border, and it never repeated. Okay? So basically, I can get really close to 6. But the binary number is then like this long. It would be like pi. It would never end because you cannot get a 0.6. 0.1 is another one. You can't get 0.1. That's why 0.6 don't work. .35 may be another one. But they can get really close. So it's close enough for what we do. But it'll never get to an accurate place. So there are numbers that cannot accurately be converted from decimal to binary. Everything can above 1, but sometimes things less than 1 can't be done.
How far is sufficient to go? I mean, how many digits? Like 6, 5, when you stop?
When you decide I've gone far enough. Or if you're asking on my stuff, when I tell you it's far enough. I'm going to say for us, I don't think I'm going any more than 4 or 5 decimal places. So let's just say 5. If it goes past 5, just put little dots out there so we all know it goes past this. So like if I were writing this down, it would be 0.100100 ... Okay, just so that way everybody knows that it's going further, but that's as far as I'm willing to go. Okay? Oh, sorry. Thank you. All right, so y'all okay with how to do decimal numbers? They're not as hard as they look when you first look at them in the book. Now, in your lab book, it's going to ask you to convert. Oops. It's going to ask you to convert hex decimals, and I mean hex decimal places. So you would have something like 2F point CB. That's kind of pitiful looking, isn't it? 2F dot CB, and we're going to convert that to binary. What's a 2? Everything, because this is hexadecimal, Because this is hexadecimal, everything has to be written in how many? Fours, right? Groups of 4. So what's a 2? 0, 0, 1, 0. Everybody understand that? Column weights, 1, 2, 4, and 8. No 8s, no 4s, a 2, and no 1s. Yes? Who said no? Okay. Oh, you're going to have to go back and listen to that lecture you missed. Not much I can help you with, I'm sorry. All right, how about an F? All right, then you just put down the point, and what's a C? 1, 1, 0, 0. What's a B? Yeah, 1 less than a C. So 1, 0, 1, 1. So the answer to 2F dot CB is 0, 0, 1, 0, 1, 1, 1, 1, 1, 1 dot 1, 1, 0, 0, 1, 0, 1, 1. So all you're doing is you don't have to worry about the decimal place really on these. What you need to worry about is just converting the 2 to what is a 2? The F, what's an F? The C, what's a C? And then what's a B? The dot means something whenever you're doing your calculations or whatever. But as far as you converting hex to binary, it really doesn't matter. I mean, it does mean something. It's like saying, is this the same as this? No, it's not. Particularly because I put that dollar sign out there, right? But they're not the same, but they're both 12s. But the weights are different. If I went back in and I looked at these, this is 0.5, a 1 and a 0.5 and a 0.25. So if I go back now and get those a decimal number for these, then yes, it makes a difference to me. But converting it doesn't, is what I'm trying to say. All right, questions on this? Do we need to do one more? Yes, sir. How would you find your decimal places? I'm missing something in the question. Oh, you mean to take this and get it back to a decimal number? Sure, I can do that. Do y'all have this written down? Because somebody's got to call it back out to me. I can't keep flipping back and forth. Okay. All right, so if we're going to convert this binary decimal or this binary fractional number back, so what was that number? Yeah, what was the binary number for that last one? 0, 0, 1, 0. Okay. Okay. All right, so now if I were going to do this, I'd have to come in here and get my column weights. Now, I still do this in groups. So I do the easy ones for me first. So 1, 2, 4, 8, 16, 32, and I have no ones past that, so I'm going to stop. So now I'm going to add 32, 8, 4, 2, and 1. All right, so my whole number over here is 47. You with me? Your question, are you with me? Okay. If you ask me the question, I like to make sure you understand what I'm doing. So, all right. The next half we're going to do in fractional numbers, right? So this is 0.5, 0.25, 0.125, 0.0625, 0.03125, 0.01625, I believe. 0.15625. Okay. Okay, give me that again. 0.015625. Okay. All right, what's the next one? 0.0078125. And the last one? 0.039. So now that I have all those column weights, I'll try not to give you all this many on the test. I might give you that to convert to binary from hex, but I'm not going to give you these this far to convert it on the test. But the hard ones are better in class anyway, so that's, so that's okay. All right, so now all we need to do is we need to add a half, 0.25. It's not so bad if you're doing it with your calculator. It's just kind of bad when you're trying to do it in your head. 0.03125. I'm going to run out of room. 0.0078125 and 0.00390625. And my calculator is across the hall. So somebody want to add that for me? Did my recording go off? What you got? 0.79296875. I got 8.5. No, 7.5's right. Okay. That's right. So your answer would be 47.79296875, or somewhere close to that. Well, it'll also, I'm actually going to put this up on Blackboard as soon as I finish too, so you'll have these.
Did we have 5 ones for the F or 4 ones? I missed that.
For the F, 4.
Okay, somehow I copied 5. So
well, everything is in groups of 4.
Right.
And I don't know if this is still recording or not, guys, so. Yep. But see, that's what I'm telling you. You're 0.8's another one of those that you'll probably never get to. Because see how close I am on 0.7929? But getting to 0.8 may be another one of those. Actually, I could get a little closer. 0.575. Well, anyway. But decimal numbers are a lot more difficult. So we'll have a few of those on the test, but not many. All right, now do y'all think you can go back and do problems 2 and 3? What is D on number 2? Is it? Okay, it doesn't have, okay. I thought the decimal was up between the other ones, and I thought, oh my Lord, that's going to be a long one. I'm just going to take it off. But if it's just 0.001, I'm okay. All right, so questions on this? All right, 0.6 is not exact. I'm going to put that on there too, just so you have it. Can I erase it yet? Or can I go away from it yet? Muhammad, what about you? You got it? Or okay, that's fine. I'm all right. Three B? Yeah, but that's not 0.6. That's 0.625. 0.625, there's an answer for. 0.6 is not an answer for. It's more of a, there is an exact answer for 0.625. Just not for 0.60. What? What's the answer? What? It's point what? Yeah, let's don't do E. Just do through D on that one. So number 3E we will not do. .00125. I don't even know if that's a. I'd have to go back to all my answers again and try to do them. All right. Now I got to figure out how to get this. Come on.